Hello and welcome back. This is another 8th grade math video. And in this video, we're going to be evaluating exponents that have fractions as bases and decimals as bases. Okay, so here's the first one we're going to do. We're going to evaluate this exponent when we have a fraction for a base. So I'm going to go ahead and rewrite this so that that denominator and numerator are right on top of each other. Wrap it in the parentheses and put the second power. That's just because I prefer to look at it this way. If it doesn't bother you that it's with a slash and it's kind of on the same line, that's totally fine. So the first thing we want to do is we want to distribute that second power to both the numerator and the denominator. So what I'm going to do is distribute it here and here. That means this becomes 1 to the second power over 2 to the second power. Then I would just evaluate both of those as if I was just evaluating exponents with whole number bases. So 1 to the second power is just 1, and 2 to the second power is 4. So our final answer here would be 1 over 4. Okay, here's our next one. We're going to evaluate this exponent where the base is 1/2. So we've got 1/2. We wrap it in parentheses and put to the third power. So first thing, I want to distribute that third power to both the numerator and the denominator. So I'm going to rewrite that as 1 to the third power over 2 to the third power. Well, 1 to the third power is 1, and 2 to the third power is 8. Now, if you're not sure how I calculated that, please review some of my previous videos on how to evaluate exponents. All right, so the final answer here would be 1 over 8. Okay, so this next one we're going to do is going to be a decimal base. So I'm going to go ahead and write this out as a multiplication expression. I'm going to do 0.5 times 0.5 times 0.5. Okay, that's because the little exponential number tells us how many times or how many numbers we're multiplying, and the base tells us what number we're multiplying. So this is times and times. The reason I did that is because this will make it easier for me to visually see how many places I need to move the decimal at the end of this. So as you know, when you're multiplying decimals, first you ignore the decimals and you multiply, and then you end up moving it a certain number of spaces. So we're kind of going to do the same thing here. What I'm going to do is I'm going to multiply 5 times 5 times 5. Well, I know that 5 times 5 is 25. And then if I multiply that by the third 5, I believe I'll get 125, but let's just make sure. 5 times 5 is 25. And then 2 times 5 is 10, plus 2 is 12. So yep, it's 125. I'm going to go ahead and write that here. Then I'm going to go ahead and add a decimal to the end of that answer. And I'm going to move that decimal to the left the same number of spaces as I had decimals in my problem. So I had 1 5, another 5, and 3 5s all together that were in decimal place values. That means I'm going to move this decimal 1, 2, 3 spaces and put it right there for the answer. So the answer ends up being 0.125. That's why it's important to kind of write this out as a multiplication expression so you can see exactly how many spaces you need to move the decimal at the end. Okay, here is our next one. We have 1 over 4. So I'm going to go ahead and rewrite that as 1 over 4 in parentheses to the fourth power. Okay, so let's distribute that fourth power to the 1 and to the 4. So this becomes 1 to the fourth power over 4 to the fourth power. Well, 1 to the fourth power is 1, that I know. But 4 to the fourth power is a little bit harder for me to do in my head. So I'm going to come over here and write that out as a multiplication expression. So I'm going to write that as 4 times 4 times 4 times 4. Well, I know 4 times 4 is 16. So those two are 16, and these two are 16. So for my final answer, I just need to multiply 16 times 16. So since I can't really do that in my head either, I'm going to come over here and do that. 6 times 6 is 36. 1 times 6 is 6, plus 3 is 9. Then I would cross that off, cross this off, add a 0. I'm going to go ahead and delete these down here just so they're out of my way. Then 6 times 1 is 6. 1 times 1 is 1. I end up with 6 here. 15 here, and a 2 here. So the final answer ends up being 1 over 256. Okay, here is our last example for today's video. We're going to evaluate 0.01 to the first power. I want to make this a little more interesting because we know any base to the first power is just that base. Let's make it to the third power, make it a little more interesting. So I'm going to go ahead and write out 0.01, 0.01, and 0.001 3 times. So just like we did earlier in the video, it's important to write this out as a multiplication expression so you can see how many places you'll need to move the decimal. So I can go ahead and multiply those numbers that are not zeros, 1 times 1 times 1, and I would just end up getting 1. So I'm going to go ahead and put that there and put the decimal right after it. Now I need to move that decimal to the left the same number of spaces as there were decimals in this problem. So 1, 2, 3, 4, 5, 6. I need to move this 6 decimal spaces. So I'm going to go 1, 2, 3, 4, 5, 6. With my empty spaces, I'm going to put zeros. 0, 0, 0, 0, 0. So my final answer ends up being 0 point, then 1, 2, 3, 4, 5 zeros, and a 1. Okay, so you can see how this gets very small very fast. All right, you guys, thank you so much for joining me today. Hope to see you in another video soon.